Today we're going to talk about how to write verbal expressions, in other words, a sentence or something close to a sentence. It doesn't have to be a complete sentence. But we're going to write verbal expressions based on an algebraic expression. Then on the back side of this page we'll do the opposite. We'll start with the verbal expression and write an algebraic expression. So these are two examples. Write a verbal expression for each algebraic expression. So again, what you see here, 6n squared, and here n cubed minus 12m, those are the algebraic expressions. So numbers, exponents, variables, things like that. Now, this example, we have 6 being multiplied by n squared. So since the main operation that's going on here, the thing that connects the 6 and the n squared is multiplication. So we use the word product. So this is the product. Product means we're multiplying 6 and n squared. Now you don't have to write 6 as SIX. You can just write the number 6. And anytime you have a variable, you can just write that letter. But for the exponent, we do have to write out the word squared. As we look at B, the main operation connecting n cubed and 12m is subtraction. So we use the word difference. So the difference of n cubed and 12 times m. So you don't have to say the product of 12 and m. You just have to use the words like product and difference to describe the main operation involved in the expression. So almost all, there's exceptions I'll point out in the examples, but almost all of these, your answers should either have the word sum for addition, difference for the subtraction, product for multiplication, and quotient for division. So all of your answers, with just a couple exceptions I'll point out, should have one of these words in them. So make sure you understand which one of these words goes with which operation. So as we look at the first example, it says write a verbal expression for each algebraic expression. So the main operation happening here is subtraction, the w minus the 1. So we need to start by saying the difference. That's pointing out we're subtracting by using the word difference. You can say between, but just to be consistent, I'll try to always use the word of, because if you look, they always say product of, difference of. They'll also say sum of and quotient of. So the difference of w and 1. So difference is what we write because we're subtracting. And we just write and in between the two things that are being subtracted. So don't say minus or subtracted, because that's like saying the same thing twice. You're already pointing out the subtraction with the word difference. So in number 2, the main operation here is the addition. That's what's connecting the 81 and the 2x. So since we're adding, we would say the sum of 81, and for this we have to say 2 times x. Now in number 3, we have one of the exceptions. So there's not any adding, subtracting, multiplying, or dividing happening here. So we don't need to see one of the words sum, difference, product, or quotient in this one. This one we just have a number and an exponent. So all we have to write is 8 raised to the 4th power. And I won't be picky if you use the word power. Now, if you say 8 to the 4th, oh, I forgot the word sorry. If you just say 8 to the 4th, I'll accept it. 8 raised to the 4th, 8 raised to the 4th power, 8 to the 4th power, that's all fine. Okay, number 4, the main operation is addition. That's what's connecting the 2n squared and the 4. So I start by saying the sum. Say the sum of, that's 2 times n squared. And, I put the and where the operation is, 4. So the sum of 2 times n squared and 4. Number 5, the main operation is subtraction. That's what's connecting 2x cubed and 3. So we'd say the difference. The difference of, oh, I forgot the word of up here. I'm sorry, I'm not being very careful. I gotta be better. The sum of 2 times n squared and 4 on the previous one. And 5 is the difference of 2 times x cubed. And if you say x to the third power, I would count that too. But I'd encourage you to just use cubed because it's shorter. The difference of 2 times x cubed and 3. Number 6, we actually do have an operation because 1/4 is being multiplied by b squared. So the product is how we'd start this one. The product of 1/4 and b squared. It's okay if you say b to the second power, that's fine. On number 7, our main operation is adding, so we'd start by saying the sum of 3 times x and 4. Last one on this side of the page. Again, our main operation is adding, so we'd start by saying the sum of, we've got to make sure we describe this term correctly. 3b squared, so 3 times b squared, and, always put the and where the operation is, 2 times a cubed. So pretty much all of these, I know number 3 was an exception, but pretty much all of these, the pattern is you'll say the sum, the difference, the product, the quotient of, then you describe the first term, put the word and, wherever the operation is, and then describe the second term. So now, let's work backwards. This time, a lot quicker and easier. We start with the verbal expression, the thing that looks like a sentence, or part of one anyway, and convert it to an algebraic expression. So 4 more than a number n. So they wrote 4 plus n. Addition, the order doesn't matter, so it's okay if you just write n plus 4 or 4 plus n. So this says the difference, so when we see difference, we know they're subtracting, of a number squared. So here they just said a number. It's fine to use n, but since they didn't describe the variable with a letter, you can use any letter you want. You can say x squared or n squared, t squared, whatever. So the difference of a number squared and 8. So where the and is located, we know that's where the operation, in this case subtraction, will go. So n squared minus 8. I want to go ahead and, well actually, we'll see an example, so I'll get there later. Okay. Almost always, you want to put things in the order they're listed in the sentence or the verbal expression. And I'll show the exception. There's really just one big one. But in general, you want to put things in the order they're shown. So a number, we can put any variable we want, decreased by minus 8. 10, a number, divided by 8. And I would accept it written like this, or like this, or like this. You only have to write one of these. I'm just saying all 3 of them would be an acceptable way to write it. 11 says a number squared. 12, 4 times a number. Now if you want to write 4 times a number, that's fine. Those are both good answers. You don't have to write that though, because it's assumed when you write a number and a variable next to each other. But both of these answers are good. A number divided by 6. Okay, now here I know we could say n times 37, because the number multiplied by 37, and I won't, I'm sorry, wasn't very visible there. I won't count that wrong, but mathematically it's more normal to write the number first and the variable second. But again, I won't count it wrong because that is equivalent to that, but 37n would be the more normal way to write that. The sum, so I'm adding 9 and a number. Now, here is the big exception you must remember. This phrase right here, less than. This is the big exception you've got to remember, where you do things in the opposite order that they are in the verbal expression. So normally we think, okay, 3 less than minus 5n. But that's not correct. If you want to be 3 less than 5n, you have to be 5n minus 3. Because that's 3 less than, or 3 below 5n. So one example I can give, let's say you have a friend who's 5 feet tall. So we'll say that's, well, let's just say 5 feet is 60 inches. And you say, well, I'm 4 inches shorter than him. In other words, my height is 4 inches less than him. You wouldn't say, okay, 4 inches less than 60. So my height is negative 56 inches. That doesn't make sense. You can't have a negative height. So whenever you say less than or shorter than or anything similar to that, you have to put that other number second. Because it does make sense that you would be 56 inches tall. So you got to stick in your mind that less than means put the terms in reverse of the order they are in the verbal expression. Okay, 17 is not an exception, but it is something new we haven't seen yet. This says twice the sum. So twice means 2 times, so let's go and write that twice, but it's twice the sum of 15 in a number. So it's not just twice the 15, it's twice the sum. So I need to put parentheses around 15 plus n, because that 15 plus n is the sum of 15 in a number, and we need to be twice that much. So we would need to add those together, then multiply by 2. So twice the sum of 15 in a number. 18, 1/2 the square of b. Square of b is the same as b squared. Okay, 19, 7 more than the product of 6 in a number. So you can write this as 7 plus 6n or as 6n plus 7. Because with addition, order makes no difference. If we plugged in a number for n, we'd get the same result in this one and this one. Because adding, you can do it either direction. But subtraction, you can't. You change the order, it changes the answer. So that's why when we're adding or multiplying, if you do a different order, it doesn't matter. But with subtraction and division, it does. Last one, 30 increased by plus 3 times the square of a number.